Okay, so good morning. Is it morning? Yeah, okay. How are you guys? Today, I want us to look at hyperbolic functions, how you define them, and then how you differentiate these functions. So, I will just introduce a few. The rest you can be able to define for yourself. So, like I've written, y is equals to the cos of h, or you can simply say y is equals to the cosine hyperbolic of x. We have y is equals to the sine hyperbolic of h, y is equals to the tan hyperbolic of x, and many more. You can list many more. For example, you can add cosecant hyperbolic, you can add cot hyperbolic, and so on and so forth. Now, the way to define these functions, just like we did with the trigonometric functions, is to use the special number e, the exponential e, and then the only difference between the trigonometric functions and the hyperbolic functions is that when you expressing e with the power theta, it doesn't have the complex letter I, and therefore we can write sine hyperbolic of theta is equals to e theta minus e negative theta divided by 2. And if you want to write tan, say for example, the tan hyperbolic of theta is just expressing one on top of the other. We know that this is the sine hyperbolic of theta divided by the cosine hyperbolic of theta, and therefore we can be able to write that expression down there. Now, the way to get the derivative of these functions, the way to get the derivative is simply differentiating this function that we have written there. So, for example, find dy over dx, given that y is equals to the cos of x. So we start by defining cos. So cos of x is the same as e x plus e negative x divided by 2. Meaning, if I want the derivative with respect to x of y is the same as the derivative with respect to x of cos of x, which is equals to the derivative with respect to x of e raised to x minus, plus e negative x, then you divide by 2. Now, we all know how to get the derivative of the exponential. It is that function, and then you differentiate the power, so the power there becomes 1, so you're multiplying by 1 plus e raised to power x, you multiply by the derivative of the power, which is negative 1, and then you divide by 2, which becomes e x minus e negative x divided by 2. Now, by definition, this is the sine hyperbolic of x. So the same can be done for sine hyperbolic. We can be able to do a similar thing to get the derivative of sine hyperbolic. So I want us to do that one. So I want to erase this and then try to work it out. So I'm erasing this one. And here I want to put what we want. So now this is sine hyperbolic of x. So the derivative, first we want to define what this is. So we're saying that sine hyperbolic of x by definition is e raised to x minus e raised to negative x divided by 2, meaning that if I want the derivative of y with respect to x is the same as the derivative with respect to x of e x minus e negative x divided by 2, which should give me e x multiplied by 1 minus e negative x multiplied by negative 1 and then divided by 2. So this is equals to e x plus e x negative divided by 2, and by definition this defines cosh of x, and therefore we can be able to write down that derivative of sine hyperbolic is cosh, and the derivative of cosh of x is the sine hyperbolic of x. So that is something that we can be able to write down here, and then after which that can be used to work out other examples. So if we now write that in general, derivative with respect to x of sine hyperbolic of x is equals to cosh of x. Okay, is equals to the cosh of x. Derivative with respect to x of cosine of x is equals to the sine hyperbolic of x. And if we introduce something else to it, say for example, it's not just x, okay? If we pick another example here, we can write find dy over dx given that y is equals to sine hyperbolic of 3x squared. It therefore means that by definition we're going to have by definition y becomes e 3x squared minus e negative 3x squared divided by 2, so that the derivative with respect to x, the derivative of y with respect to x is the same as the derivative with respect to x of e 3x squared minus e negative 3x squared divided by 2. Now this is equals to e 3x squared multiplied by 6x, okay, the derivative of the power, then minus e raised to negative 3x squared, then 6x there. This one has a negative, so this one should have a negative. This one has a negative there, and then you divide by 2. So this can be factored out. 6x is common, then we have e 3x squared, a negative and a negative is a plus, e negative 3x squared divided by 2, and by definition this is simply 6x 6x what? So by definition this is what? By definition this is 6, just a minute, is 6x. Inside we have cosine hyperbolic 3x squared. So it's similar to what we were doing in trigonometric functions. The only difference is that the negative, you see, when you get the derivative of sine of x, you get cosine of x. That this is in trigonometric functions. And when you get the derivative of cosine of x, you get negative sine of x. So for this case, for the hyperbolic functions, the negative disappears. So when you get the derivative of cos of x, it doesn't give you a negative sine hyperbolic. It gives you sine hyperbolic of x. And therefore, we can increase this so that we can write derivative with respect to x of sine hyperbolic of g of x. Okay, this one should give us cosine hyperbolic. Sorry. This is a big mistake I've made here. Okay, this was supposed to be like this, and then g of x, so that the answer becomes g prime of x and then sine hyperbolic of g. So this is similar to what we did in trigonometry, apart from we have said that the negative does not appear anywhere. And therefore, if you do derivative with respect to x of cos of g of x, we expect to get g prime of x, then sine hyperbolic of g of x. And yes, so these are the formulas. These ones, you can apply them, and yeah, they're easy to work with. Okay, they're easy to work with. So I think I can give you a number of questions here to try at your own free time. Okay, just try these ones at your own free time. To retain the formulas there. Okay, so I just want to pick an examples. Find dy dx given that 1 y is equals to cos square root of x, 2 y is equals to x squared sine hyperbolic e 2x, 3 y is equals to x squared plus 1 raised to 7 divided by cos of 5x. Number 4, y is equals to cos logarithm of 2x, like that. And then number 5, y is equals to ln of x divided by tan of 2x. These are questions you can try, and if they're just, it's just a variation of formulas. And what I want to do is I just want to do one. of these questions. And I'm picking on question 3. Okay, question 3. So for question 3, it is y is equals to x squared plus 1 raised to 7 divided by cos of 5x. So since this one is a fraction, we say let u be equals to x squared plus 1 raised to power 7, meaning u prime becomes 7 x squared plus 1 power 6 and then 2x. V is equals to cos 5x. V prime becomes 5 sine becomes 5 sine hyperbolic of 5x, meaning change in y over change in x is equals to u prime v minus u v prime divided by v squared. This is equals to u prime is 14x squared plus 1 raised to 6 multiplied by v, which is the cos 5x minus, it's a minus, this is x minus u, which is x squared plus 1 raised to power 7, and then we multiply by v prime, which is 5 sine hyperbolic 5x, and then we divide everything by v squared, so cos square 5x. So if you simplify this, x squared plus 1 power 6 can be factored out, meaning x squared plus 1 raised to power 6 factored out gives you 14x cos 5x. Then plus minus, x squared plus 1. I should have started with a 5 because there's a 5. There's a 5 here, and then x squared plus 1, and then sine hyperbolic 5x, and then everything to be divided by cos square 5x. And this is a good answer. You can leave it at that. So what I want you to do, I want you to try the others, and that will be a good exercise for the derivatives of hyperbolic functions. Enjoy as you try these questions.